Thank you for the invitation to the Final Cities Consortium meeting. And during the last 7 years, I really enjoyed the collaboration with the Cities Consortium, especially DTU, Professor Healing Medicine. Today, I will talk about the recent research regarding to the optimal operation strategy of large-scale CHP. And in the final paper, in the latter part, I will talk about the experience of the collaboration with the DTU. Today's contents are very brief Korean electricity market introductions and the challenges we are facing to go to the CO2-free in 2050. And today I will talk about the Korean district heating system and the business models. And after that, I will talk about the characteristics of the larger scale CHPs and the optimal operation strategy of the larger scale CHPs on the electricity market and the district heat demand. And finally, I will talk about the conclusion and the future collaborations with the DTU and Denmark. The Korean power system is the isolated one, not interconnected with the neighboring countries, not interconnected to North Korea, to Japan, China. So very, very isolated and population dense power systems. And the total installed capacity is around 130 gigawatt. And the high density of the network due to the constraints, concentration of the supply and the demand in metropolitan area. And the present capacity mix is highly focused to the fossil fuel. For example, 31% of the coal power plant and the LNG gas is around 32. So the renewable is only 12% and the nuclear is 80%. So 30% of non-fossil and the others 70% capacity is focused on the fossil fuel power plants. So we need dramatic changes within 20 and 30 years. And the market structure is very much focused on the generation competition. So we do not have a full competition electricity market. The retail side is monopolized by the Korea Electric Power Corporation in retail. So only half of the electricity market is open to the private as well as public companies. Next, I will talk about the district heating system in South Korea. We have two kind of business models and for the district heating. One is that for residential and commercial buildings, provide the heat and the cooling. And the second one is regarding to the industrial complex and its price. That if we have the factory areas, then some company can provide the heat and the steam to that area with the CHP. So we have two kind of business models regarding to the district heating. So if we see the system configuration here, This one is the district heating company, which owns the CHP and peak load boiler, and it can have the some heater storage and electricity storage. If this company, the CHP produce heat, then heat is provided to the captive customers for the residential and the commercial customers. And the byproduct electricity is also provided to the captive customers. And if the residual extra electricity is generated by CHP, then the electricity is sold to the grid based on the system marginal price. So our system, today's topic is focused on the optimization of the this district heating system with the CHP, PRV, and heat and electricity storage. Today, about 14% of the total residential customers in South Korea is provided by the district heating and cooling. And regarding to the total capacity, about 10% of the total power plants is the CHP format. And very similar figures regarding to the total generation from CHP. It is around 10.6% from the CHP. Today, I will talk about the large scale CHP. Large scale CHP is very common in South Korea since we live in a very dense apartment metropolitan area. So normally 500 megawatt CCGT with are installed nearby our residential, very complex residential area. So this one is the figure is the typical CCGT based CHP mode computations. And normally we have the normal three modes: mode 1, mode 2, mode 3. Mode 1 is regarding to the back pressure operation, which the operation facilities include gas turbine, HRSG, steam turbine, heater storage. And the mode 2 is some kind of extraction condensing operation. And the mode 3 is a condensing operation, which produce own electricity. In summer seasons, we do not have heat demand. So this CHP is converted to the conventional CCGTs. And we do have some abnormal mode when some system is fails, and if you need to some emergency operations, we use these two, mode 4 and mode 5. And here we can see the detailed modes of the CCGT-based CHP system. Mode 1, mode 2, mode 3 is normal operations, and the mode 4 and mode 5 is abnormal emergency situation operations. Here we can define the operating characteristics of the CCGT-based CHPs. The x-axis explains the heat generation. The y-axis implies the electricity operations. As we have discussed, the mode 3 do not produce heat, so it lays this area, y-axis area. And the mode 1 is following this line, which means that if we produce the heat, then the corresponding electricity is produced based on the y-axis value, and the mode 2 is more flexible areas. So we modeled these modes, independent generators, and we added the intra-mode systems. It means that if we change the mode between mode, then we added one dummy generators when changing the mode. So this kind of formulations and system implementation is done in this study. So the goal is to determine the optimal operation modes of the large scale CHP that can maximize profit while satisfying the heat demand and the several operating constraints of the each facilities. So the main research contents is summarized here. And we can see the simple case study. We applied 2 weeks in winter, and the price and the cost of electricity and heat and the fuel is given, and the heat load is also given. Then we have 5 modes: mode 1, mode 2, mode 3, and the mode 1 and 2 implies that the mode changing period mode. And we have the technical data for the electricity and the heat generations. So we optimize these modes during for this simple case study. Also, we included peak load boiler and heater storage tank, ACC, and electricity system, ESS. So this is the simple result of the optimization. Single mode 1 implies that if the CCGT has only mode 1, then the objective function, the profit becomes 5,158. And if we consider it has only mode 2, then 4,940. And if we consider the 3 mode and the intra 2 mode, then the profit and the profit can be increased to 5,363. And we see the heat output configuration, and in the right figure we can see the electricity output as well as the most outputs from the CCGT based CHPs. And today I have talked about a very brief overview of the Korea electricity market district heating systems, and a very brief introduction of the recent research on the operational issues and optimal operation study of large scale CHP, considering the detailed technical modes. And we ideally enjoyed the collaboration with the DTU during the last 7 years, and we had the graduate student exchange program and collaboration research. And I think that we need for more close future collaborations, since in these days South Korea has increased the renewable target to the 35% in 2040. And we last week the president of South Korea has announced that the net zero in 2050. And the South Korea power system is a very isolated system and a very high peak system. So we need to solve this problem within 10, 20, and 30 years. Denmark has a very many accumulated experience regarding to the power system operation, highly depends on the renewables. So I think that more and more close future collaboration and co-research will be needed. And I think that the role of CHP and the heat storage for increasing the power system flexibility. Helix said that sector coupling flexibility is very needed in these days. So I think that the South Korea and Denmark can focus on the field test regarding to the heat storage flexibility provision to the electrical system. Thank you so much.
Thank you very much, Professor Yongbei Park. We actually have a few questions that we have time to put back to you. And first, I will pass the word to one of our speakers later today, who is Mr. Jan Hvidbjerg from the big company, energy company Ørsted. Jan, can you unmute yourself and then please raise your question?
Hello, and thank you for your presentation. In Denmark and in my company, we have been through the same process as you describe here today for many years. But what we are currently working on is implementing large-scale electric boilers and heat pumps in our district heating systems. Do you think that is possible in a Korean context as well?
I think that at this time, we have two power systems. One is Jeju Island, 1% of island system, and the 99% is peninsula. In Jeju, the portion of the renewable is increased to the 15%. It means that at this time, the retail renewable curtailment is very common from this year. So we are thinking about how to increase the flexibility by applying heat storage in the winter seasons. And I think that if your experience regarding to the heat pump for the cooling services, that kind of cooling and heating system will be needed in a near future in the peninsula and very, very urgent in the Jeju Island at this time. And if I add one more thing, that we do not have the ancillary service market in South Korea. So I am very actively engaged in to open the ancillary service market to the other coupling energy sectors, for example, heat or cooling. So I think that your experience regarding to the ancillary service market, including heat and other P2G or other experiences will be very, very helpful to South Korea.
I can say in the Danish context, the ancillary services and favorable taxes for electricity to heat and cooling is two super important factors if you want to drive more flexibility, electric flexibility into your heating systems.
Yeah. Then please send the email and Helix, would you make some, yeah.
Yes, I have a question on district cooling, because you mentioned that 14% of Korea has district heating and cooling. How popular is district cooling? The reason for mentioning that is that here in Scandinavia, in Sweden, they have a lot of district cooling, but actually not in Denmark. But do you have the 14%? Do they both have district heating and district cooling? So, and how do you yeah, how is that operating?
Yeah, at this time, the district heating is the main services in the winter seasons. But in summer seasons, we need the cooling system using the extra energy from the CHPs. So we started to make some demonstrations for the district cooling systems. But at this time, not so common at this time.
Do you use district heating for cooling, or is it a separate cooling network?
The same network, the same
Okay.
network.
Okay. Thanks a lot for an very, very interesting talk and for the collaboration.
Thank you.